As we celebrate 100 years of quantum mechanics, one of its most powerful applications, a quantum computer, is now on our doorstep. In fact, right behind me, you can see a quantum computer in action. This machine has been built by the French company Quandela. To find out more about it and its applications, I am now joined by Valérien Giez, who is the Chief Operating Officer of Quandela. Thank you very much for your time. What is a quantum computer and why is it considered to be revolutionary?
Quantum computers are machines using entanglement, superposition to solve problems that traditional computers cannot solve nowadays. For example, if you want to discover new drugs, if you want to simulate new materials, our traditional computers, super large supercomputers, are now limited by the laws of electronics. With quantum computers, we will be able to solve very complicated problems, and we will be able to discover new drugs more efficiently, discover new materials for industries, and will be more efficient.
Can you tell us about the machine behind you?
This machine, it's a state-of-the-art in terms of computing power based on quantum computers. Here, the machine is unique because actually it has been developed by Quandela. It uses light, particles of light, photons, to do computations. So we generate a lot of photons inside these machines, and we combine these photons into circuits, photonic circuits, to run some computations. Inside, we can use the entanglement between the photons, the superposition between the photons, to solve problems that traditional computers cannot solve. Actually, we have developed two quantum computers with 12 qubits. One is behind me and is available for our community in the cloud. So we have about 2,000 users, researchers, developers, students using these quantum computers for their own research to learn how to use a quantum computer. And in parallel, we just finalized the assembling of a quantum computer that has been delivered to CEA, Supercomputing Center here nearby Paris in Briare-le-Châtel. This project has been funded by EuroHPC, part of a European strategy to provide quantum computers for European community of researchers. So we have been part of this project. Quandela has been selected through an international and European call. And it's a state-of-the-art. This is the most powerful photonic quantum computers available in data centers.
What's the difference between a conventional computer and a quantum computer?
Differences are huge. By using entanglement, superposition of states, all of this that has been discovered by quantum mechanics 100 years ago, we will be able to solve problems by million times faster. So quantum computers will be a revolution for our industry, for digital industry. So we will just be able to solve what is not solvable now. For example, if you want to factorize big numbers into prime numbers, which is one of the key for cryptographic communications, one traditional computers will require thousands, millions of years to solve these problems. With a quantum computers, it should be solved within days. So quantum computers, in one word, will transform millions of years into days.
When will quantum computers be available for practical day-to-day use?
So now we have about 100 of quantum computers available around the world. Quandela has delivered quantum computers in France, in Canada. We recently delivered a quantum computers to the CEA Supercomputing Center. And now the machines behind me is a quantum computer which is available in our cloud. So we have machines available for research academy, researchers, academia, corporates can use these machines. But they are not practically useful yet. We predict that within 5 to 10 years, quantum computers will be particularly useful for corporates, for researchers to develop new materials and new techniques in different industries.
What are the challenges in developing this technology further?
This is a good question. We are now at the beginning of a new era of quantum computing and in computing in general. we have solved many scientific challenges during the 100 years. All the community of researchers have developed techniques to make it possible. Now we need to make the possible ready for industrialization. So next challenges are about industrialization of quantum computers, how to scale these quantum computers for useful applications, as you mentioned, and how to fabricate dozens, hundreds of these quantum computers to solve and to make them available for industry. That's the future challenges that will come in the next years.
And finally, can you tell us about Quandela?
Quandela is a startup spin-off from CNRS and University Paris-Saclay Lab. Now we have about 150 employees around the globe. Most of the teams are located in France, but we also have labs and offices in Germany, in Canada, in South Korea. We are now expanding internationally. We are one of the first to deploy photonic quantum computers. We believe that photonic technology will be the most promising way to build scalable quantum computers and make them available for corporates and industries.